Welcome back to the lecture series of power electronics. In this session, I am going to derive the relation between input and output voltage of step-up chopper. Also, you will come to know the expression for step-up chopper. You already know that step-up chopper is also known as DC-DC boost converter. In the last session, let me have a recall. I discussed about what is the meaning of boost converter. Thereafter, I discussed about how does it work during switch, whenever the switch is on, what are the changes which are happening in the circuit. Along with that, I discussed about what will happen during, so whenever the switch is off. Those two conditions I discussed. Thereafter, I discussed the waveform as well. Today, I'm going to talk about the relation between input and output voltage of the step-up chopper. All right. So let us get started the derivation. Here, you need to recall the law of energy conservation. Okay, let us talk about like energy conservation law. So energy during turn on, we already discussed energy during what will happen during whenever the switch is on and whenever the switch is off. So in this session, let us have a derivation on the relation between input and output voltage. So energy during turn on, let us write energy. Okay, energy during turn on time, turn on process. That means whenever the switch is on, that means we can write turn on. So you already know that energy is nothing but power into time. So we can write P on into T on. So P on can be written as V into I. That should be multiplied with the T on. Anyway, you know that the voltage is nothing but the input voltage, right? Vs. The I will be the average inductor current. So we can write like I1 plus I2 upon 2. Provided the device is working in continuous conduction mode, the inductor current never reaches to 0. So please call it as first equation. Now energy during turn off. Okay, you can make a note. Energy during turn off. Like we can write turn off whenever the switch is off. That means the inductor will discharge. Energy during turn on means inductor is getting charged. In second case, inductor is going to be discharged. So let me write E2. E2 can be written as P of times T of, because energy is equal to power into time. Okay. Now we will be writing like V into I into T of. Now substitute accordingly. V is nothing but the difference between the input voltage and the output voltage. Okay, that should be multiplied with the average inductor current. I1 plus I2 divided by 2. That must be multiplied with the T on. So please call it as equation number 2. Now, according to law of energy conservation, we will write E1 will be equal to E2. At a certain time, equilibrium will be established, right? So at that time, we can equate those two equations. By the way, E1, expression for E1 will be equal to E2, right? So please write down the expression for E1. So we have already called, that means equating 1 and 2. Equating 1 and 2 respectively. By the way, we'll write Vs into I1 plus I2 divided by 2 into T on must be equal to Vs minus V naught into I1 plus I2 divided by 2 should be multiplied with the T of. So straight away I can delete these two terms. I can directly cancel because the same term is repeating at LHS and RHS. Kindly rewrite the remaining terms. Vs minus V naught into T of. By the way, we can elaborate it. Let us elaborate it. Okay. So Vs into turn on will be equal to, we can remove the brackets, T of into Vs minus Vs into, sorry, V naught into T of. So now, let us separate V naught into T of in one side. I'll be writing V naught into T of, that is nothing but Vs into T on plus T of. Okay. So V naught can be written as Vs into T on plus T of divided by T of. T of. We already know that T on plus T of, that is equal to total time period. So divided by T of. So note T is equal to T on plus T of. Now I wanted to replace T of. Okay. I want to replace T of in the form of duty cycle. So we already know that. So we call it as equation number 3. Okay. Let us continue the derivation. So we have total time period T is equal to T on plus T off. So duty cycle D is equal to T on by T, thereby T on is equal to dt. Correct. So what you are supposed to do is T is equal to, instead of T on, I am going to put dt plus T off. From this, please separate the value of T off because I want to replace T off, correct, in terms of duty cycle. T minus dt. Now, T can be taken outside, 1 minus D. Okay, so we'll write T off. So call it as equation number 4. Okay. Now 3 is available here. You can note down 4 is available here. So what exactly you are supposed to do? Put 4 into 3. Substitute equation 4 in the equation 3. In the equation 3. So what will happen? So V naught can be written as Vs into T divided by T of. T of you have to replace. T of is nothing but T into 1 minus T. Let me rewrite. Okay. So let me write V naught equal to Vs into T divided by T into 1 minus D. Here it is very clear that T and T will be getting cancelled. That means Vs divided by 1 minus D. So V naught can be written as Vs into 1 by 1 minus D. Therefore, the ratio of output divided by input of a boost converter or a step-up converter, 1 by 1 minus T. So we are going to write the duty cycle. Okay. So where D is known as duty cycle or duty ratio. Duty ratio. Remember, in the case of step-up chopper, duty ratio will be always greater than 50%. Okay, that is a general fact I wanted to inform you. So this is regarding the relation between input and output and input voltage or input and output voltage of a step-up chopper or a boost converter. So practically what we are going to do is, so we are going to modify the conventional chopper, conventional step-up chopper. So in practical, the conventional DC-DC step-up chopper will be modified as, so we can modify like Vs, then we have inductor, energy storage element, then your switch, okay, power switch. Later, we'll be using the diode, power diode for the conduction. Then we'll be keeping the capacitor and that will be supplied to the load. So we call like a DC link capacitor. So see, we are going to maintain the output constant using the capacitor. Okay. So this is your switch. PH, diode, inductor, IS and I naught. Practically, the step-up chopper will be modified in this fashion. So in this video, what you have learned is we discussed about the relation between input and output voltage of a step-up chopper. So I discussed about the law of energy conservation and E1 and E2, that energy storage during on and energy storage during off will be equated to each other. Ultimately, I found out the relation between output and input voltage V naught by Vs equal to 1 by 1 minus T. Ultimately, practical boost converter, practical step chopper has been drawn on the screen. So in this session, we discussed about the idea about the boost converter. So thank you very much for watching this video. Let me know if you have any clarification. So I wanted to appreciate if you have any queries. Thank you very much for being with me. Happy learning.